Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Alga Firmansyah, and today I will presenting about AWS Cloud Practitioner. Let's start with domain 1, which covers clouds. Concepts such as what AWS is, the benefits of AWS design principle, migration, and economics. Domain 1, cloud concept is broken down into 4 tasks statement that we will cover in the next few lessons. Statement 1.1 define the benefit of the AWS Cloud. 1.2 identify design principles in the AWS Cloud. 1.3 uh, understand the benefits and strategies for migrating to the AWS Cloud. 1.4 understand the concept of cloud economics. Uh, for the first task statement, we will start with the basic of AWS. Cloud computing is not just a buzzword, rather, it is a unique type of computing that has a formal set of definition. We will dive deeper into what AWS is and explore what makes the cloud. For the second task statement, we will focus on design principle for AWS and discuss the AWS Well-Architected Framework, best practice, and key strategies for designing system with the cloud. For the third task statement, we will focus on reducing database costs and increasing availability when you migrate to AWS. We will discuss AWS storage service and ensure you understand the types of data you have and what data storage is required. For the fourth task statement, we will focus on understanding the concept of cloud economics and the step to run a cost optimized environment over the next few videos. In this module, I will explain each task statement one by one, breaking down knowledge and skill you need to master in order to succeed. Let's start evaluating your readiness for the next video. 1.1 define the benefits of the AWS Cloud. Let's start with the first task statement, which is defining the benefits of the AWS Cloud. The purpose of this task statement is to ensure you know the value of AWS. However, before you can understand the value of AWS, make sure you know what AWS is. Can you define AWS? AWS states that Amazon Web Service is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured and services. From data centers globally, millions of customers, including some of the fastest growing startups, largest enterprises, and leading government agencies, are using AWS to lower costs, become more agile, and innovate faster. So AWS give us a way to strengthen our infrastructure while becoming more agile and also lowering costs. However, you also need to understand what cloud computing is. If you are wondering of searching on Google about what cloud computing is, you will find several different answers. But cloud computing fundamentally means that you must meet certain criteria. Let's break down and quickly discuss these 5 criteria. The 5 essential criteria of cloud computing. Number 1, on-demand self-service. This is the ability to provision computing features or capabilities such as servers, database, networks, storage, and more on demand whenever that service is needed. Furthermore, cloud computing must be able to provision resources without human intervention on interaction to make it a true on-demand self-service. AWS give us the ability to do this from the console, command line, and also using application programming interface APIs. We don't need to ask or request permission from anyone. With the correct permission, you can log in and start building. Number two, network access. Cloud computing needs to have network connectivity to access and provision the necessary resources which give us the ability to build using the AWS management console, command line, HTTP, HTTPS, VPN, SSH, and many more. Number three, resource pooling. What is resource pooling? AWS provides pooled resources to serve a diverse range of AWS customers. AWS has thousands of servers, database, and more that can be available on demand to build based on our environment. And these pooled resources are available to me, you, and everyone else as well. However, another part of the third criterion we must meet is what we do not know the exact location of the spirit resorts. For example, when you run Amazon Elastic Compute Cloud Amazon EC2 instance, you can choose the AWS region, but AWS is allowed to choose any data center within that AWS region. However, you can choose an availability zone if you want. We will discuss more about region and availability zone in a few minutes. AWS provide a vast amount of resources for their AWS customer, ensuring thousands of users can leverage economics of scale. You will learn more about economies of scale in cost optimization. But for now, economies of scale allow AWS with a larger scale of research to offer massive savings to their customers. This means AWS can pass savings onto their customers while simultaneously providing the resources needed for customers to scale and grow. Number four, elasticity. Elasticity is the ability to scale with demand. As demand increases, you can scale up your OS resources, and when that demand drops, you can scale back down. Uh, five, Number five, monitor and build resource usage. The usage of research in OS account can be monitored and built with OS. We no longer pre-provision or browser storage, servers computing, and so on. You no longer need to estimate your demand because with iOS, we not only use air prices whose usage is monitored and then built, but we also dynamically scale the research to meet your exact demand rather than over on under provisioning. Biggest cost optimization benefit is what is that we only pay for what we use with AWS. Global infrastructure resiliency and scaling. So how does AWS provide such exceptional cloud computing? Well, AWS offers a global infrastructure, which is a collection of small infrastructure groups connected by a high-speed global network. This global infrastructure allows you to design resilient and highly available system. We will deeper into the AWS Global Infrastructure later in Domain 3. But for now, ensure you understand AWS regions, availability zones, and its location. Let's conclude this lesson and discuss the advantage of high availability, elasticity, and agility. Fault tolerance is usually mentioned and stood as high availability, so let's look deeper into both of this as well disaster recovery. High availability. High availability is a way to design your your system so that it has the ability to keep your system up and running and provide service as frequently as possible. This scaling is designed so that if any system component that's damaged can be replaced or repaired as quickly as possible, maximizing the system uptime. However, availability does not mean stopping failures, and it does not mean there will be no downtime or outage. What high availability does is respond when a failure occurs to fix it as soon as possible so the system can be used again. Example of high availability. Suppose we have an application running and a single server inside iOS. The server is used by employees to complete their work. This, if the server stops functioning, employees cannot work because the server is down and experiencing an outage. If you design this architecture for high availability, you can quickly spin up a new server or failover, or you can run two servers for this application, one in active mode and one standby mode. If one server goes down, you can failover to the second server to serve employees. However, in this situation, employees might have to log in again, so there might be a small amount of downtime, and that is fine. This might not be ideal, but with high availability, some downtime can occur depending on your design. The goal of high availability is to reduce outage, remain operational, stay fast, and achieve automatic recovery, though there is usually downtime even if it's very brief. Fault tolerance. Fault tolerance is similar to high availability, but it is the actual ability of a system to remain fully operational in the event of failure. For example, even if one or more system component fail, the system can continue to function seamlessly through that failure. A fault-tolerant design must continue operating, returning to our previous scenario of we design for fault tolerance. We will have two active servers serving to a single application simultaneously. If one server stops working, the second server is already active and will continue to be usable by employees, resulting in zero downtime. A fault-tolerant design operates to minimize failures, but also continues to operate through them. Designing such systems is typically more expensive than high availability design. Next, disaster recovery. Disaster recovery is slightly different from fault tolerance and high availability because those are about designing systems to operate through disruption. Disaster recovery is about what we need to plan and what we need to do if a disaster actually strikes. Having a disaster recovery plan is extremely important because the worst time to try to recover from a disaster is in the middle of it. Disaster recovery requires advanced planning as well as the steps to complete the disaster recovery process so that when a disaster happens, you already have a plan to restore the system as quickly as possible throughout. This course we will continue to discuss high availability, fault tolerance, and disaster recovery, and how various AWS services are excellent choice for one but for all of them. Next, scaling and elasticity. Let's move on to less elasticity. Earlier on this lesson, we mentioned scaling. Scaling is the capability of a system to increase or decrease the load placed upon it. A system can be scaled up or down depending on its load. When a system scales, we add or remove resources. There are two ways to scale vertically and horizontally. Vertical scaling. An example of vertical scaling is if you have an Amazon EC2 instance of a certain size and that instance size cannot keep up with an increases in demand. As a result, the instance might start running very slowly or in the worst case scenario, cause the system to crash. Vertical scaling changes the size of your Amazon EC instance to a larger size, e.g. changing from a T2 micro to a T2 medium or larger. By resizing the instance, you add more CPU and memory, so the system can handle the increased demand. If you choose to scale vertically, you will encounter a few issues. There is usually brief description because the result instance need to be rebooted from a cost optimization perspective. Scaling vertically to larger and larger instance sizes will also result in increased costs. This is one of the areas where you can dive into the cost optimization pillar of the AWS Architect framework. Ensure you right size your instance from the start. However, some advantages of vertical scaling are that it typically requires no application modification and works for all applications. The next, horizontal scaling. Horizontal scaling is designed to fix some of the issues we face with vertical scaling. With horizontal scaling, instead increasing the size of an instance, you add more instances of the same size to handle the load instead of leaving a single copy of the application running. You now have a copy for each instance that is scaled, and you can use a load balancer to help distribute the load across all instances. However, we must consider certain things with horizontal scaling such as session. You do not want to describe customer session when you have a single application running on one server. All your sessions are stored on that server, but what happens to your session when we scale to multiple servers? Sometimes we move between instances because horizontal scaling is meant to even out the load. The load balancer send requests to different servers containing a copy of your application. You can use the sticky session feature. See that you do not lose your session when switching between servers. This works during both scale-in and scale-out events. Furthermore, regarding cost optimization, horizontal scaling is usually cheaper because you are using smaller, less expensive instance sizes. Next, elasticity defined. Elasticity is using automatically on alongside horizontal scaling to match capacity and supply with demand. You will realize that demand is rarely linear. It usually peaks and valleys. By using elasticity, your capacity can grow and shrink to match ever-changing demand. Always provides launch configuration and auto-scaling to adjust your system to the exact capacity required by demand, allowing your environment to scale out, adding research as demand increases, and scaling reducing to the server count when demand decreases, which optimizes performance, efficiency, operational excellence, and cost optimization are pillars of the AWS Well-Architected Framework. Segment 1.2: Identify design principles in the AWS Cloud. Let's start with the second task statement, which is identifying AWS design principle. The main focus for this task statement is the AWS Well-Architected Framework. For this exam, make sure you have a solid understanding of how to use the AWS Well-Architected Framework to design and build resilient, highly available, and cost-effective environments. What is the AWS Well-Architected Framework? It is a set of AWS best practice and core strategies for designing systems is in the cloud. It helps your design build and operate reliable, secure, efficient, and cost-effective system that increase your likelihood of success. Well, the AWS Well Architect framework is based on six pillars: operational excellence, security, reliable, reliability, performance efficiency, cost optimization, sustainability. The World Architect Framework also identifies a set of general design principles to uh, also identifies a set of general design principles to facilitate good design in the cloud. Stop judging your capacity. Use auto-scaling to ensure a supply will meet your demand. Test system at production scale. Automate your architecture to make experimentation easier. Allow for evolutionary architectural changes. Are that use data to drive necessary modification and improve flow. Game days rehearsals to see your system at production level. OLs also provide the well architect to alongside best practice to help us review and compare workload against the latest OS architectural design best practice, which come directly from the frameworks. The six pillars of the Well Architect frameworks: operational excellence, the ability to support development and run workloads effectively, gain insight into their operation and continuously improve supporting process and procedure to deliver business value. Its five design principles are: perform operation as code, make frequent, small, reversible changes, refine operational procedures, frequently anticipate failure, and learn from all operational failures. Next, security. The ability to protect data system and assets, to take advantage of cloud technologies to improve your security. Its seven design principles are: implement a strong identity foundation, uh, maintain traceability, apply security at all layers, automate security best practice, protect data in transit and at rest, keep people away from data, and prepare for security events. And the next, reliability. The ability of a workload to perform its instance function correctly and consistently expanded, including the ability to operate and test the workload through its total life cycle. Its life design principles are automatically recover from failure, test recovery procedures scale horizontally to increase to total workload availability, stop-wasting capacity, and manage change with automation. Next, performance efficiency, the ability to use computing resource efficiently to meet system requirements and maintain that efficiency as demand change and technologies evolve. Its five design principles are democratize invented technology, go global in minutes, use serverless architecture, experiment more frequently, so and consider mechanical sympathy. Next, optimization, the ability to run system to deliver business value at the lowest uh, price point. We will discuss the cost optimization pillar further in domain for billing, pricing, and support. Next, sustainability. The pillars focus on environmental impacts, particularly energy consumption and efficiency, as both play a critical role for architects to inform direct action to reduce research utilization. Its six design principles are understand your impact, uh, estab- establish sustainability goals, maximize utilization, anticipate and adopt new, more efficient hardware and software offering as managed service, and reduce the downstream impact of your cloud workloads. Make sure you also understand the best practice for all pillars. The AWS Well-Architected Framework is highly vital in the real world for this exam and for the AWS Certified Solution Architect Associate Certification. Okay. Statement 1.3. Understand the benefits and strategies for migrating to the AWS Cloud. Let's start with the third task statement, which is understanding the benefits and strategies for migrating to AWS. For this task statement, make sure you know how to use the AWS Cloud Adoption Frameworks, AWS CAF, and which resource can help support your migration journey to AWS. The AWS CAF is different from the AWS Well-Architected Framework. It provides a comprehensive approach to the cloud and identifies specific organizational capabilities for successful cloud transformation. AWS CIA capabilities provide best practice guidance that help you improve your cloud readiness. The AWS CIF capabilities are grouped into six perspectives: business, people, governance, platform, security, operation. Make sure you know how to use the OS CIF to identify and prioritize transformation opportunities, evaluate and improve your cloud readiness, and iteratively develop your transformation roadmap. The benefits of using OS CIF in cloud: reducing business risk through improved reliability, performance, and security, improving operational efficiency by reducing costs and increasing productivity, growing by creating new products and services to reach new customer or markets, and improving performance by increasing your sustainability and transparency. This fourth stage of cloud adoption, and the first project stage. When you evaluate whether migrating to AWS will meet your specific requirements and needs. In the second foundation stage, when you migrating to AWS begins, perhaps you move a few for product ion application to AWS or deploy an initial framework for a landing zone in a non-production environment. And the third migration stage, when you define roles for cloud operation, build a cloud anthem of excellent CCOE and prepare for long-term cloud operation instead of on-premise operation. And the last reinvention stage, when all new projects are initiated directly on AWS. Uh, an assessment of your own and your organization's current state is complete to understand your adoption stage before migration begins. The 7 areas of migration strategy. For exam preparation, making sure you know how to identify the right migration strategy, such as database replication using AWS Database Migration Service, AWS DMS, or AWS Snowball before the exam. Know the 7 migration strategies. Retire used application you want to decommission to or turn off. Retain use for application you want to keep in the source environment or application that are not yet ready to be migrated. Rehouse, leave, and shift for application migrate without marking and change to the application itself. Relocate into intended for moving a large number of server compressing one or more applications seamlessly. Repurchase, drop and shop for shifting to a different version of product that provides more value than more exciting infrastructure. The platform, leave Tinker and Shift for applications that require minor optimization to operation efficiently or leverage OS capabilities. Reflector or React re-architect for application you want to migrate to AWS while fully leveraging cloud native features to maximize agility, performance, and scalability. A migration services and target scenarios. What other AWS services and research are available to support your cloud migration journey? Suppose you are migrating an financial information application to AWS that requires low latency access and constantly changing data. Which AWS service can you use? Amazon S3 is always a great option. For low latency needs, it isn't the best choice because it resides in a public zone outside your Amazon VPC, which might incur higher latency. Our Snowball Edge is used when you need to move massive amounts of data physically into or out of AWS. The best choice. Here are Amazon EFAs and Amazon RDS. Amazon RDS is a managed database service that provides scalable relational database with fast performance, high availability, and security. Amazon EFAs provides scalable with file storage mm, for Amazon easy to instances with elastic storage capacity. Migration service and target scenarios. Resources are available to support your cloud migration journeys. Suppose you are migrating an financial information application to AWS that requires low latency access and constantly changing data. Which AWS service can you use? Amazon S3 is always a great option, but for low latency needs, it isn't the best choice because it reside and public zone outside your Amazon VPC, which might incur higher latency. AWS Noble Edge is used when you need to move massive amounts of data physically into or out of AWS. The best choice here are Amazon EFS and Amazon RDS. Amazon RDS is a managed database service that provides scalable relational database with fast performance, high availability, and security. Amazon EFS provides scalable file storage for Amazon easy to instance with elastic storage capacity. What if you are migrating a NoSQL database and must ensure it is scalable, fast, and reliable? AWS database service will you choose Amazon DynamoDB is a fully managed NoSQL database service that delivers fast and predictable performance with seamless scalability. NoSQL and non-relational are keywords for DynamoDB, just as relational is the keyword for Amazon RDS. Amazon DynamoDB is a key value and document database that stores JSON type documents. AWS also has another fully managed relational database service called Amazon Aurora. What if you need to launch a Microsoft SQL Server database on OS but need to ensure it is cost optimized and only requires and standard SQL Server license? AWS offers several Amazon Machine Image (MIS) for Amazon EC2 instance. If you launch an Amazon EC2 instance using Windows AMI, you can select an instance pre-bundled with SQL Server Standard, and you do not need to buy your own license from Microsoft. You could choose an Amazon RDS database instance running SQL Server Standard, but the question asks for cost optimization, and Amazon RDS costs more than Amazon EC2 because it is a managed service. Additionally, Amazon Aurora only support MySQL and PostgreSQL, not SQL servers. Another focus for area for this task statement is data because you need a plan to store data after it is migrated. Make sure you understand the cost storage option for AWS storage service. For example, the Amazon S3 Glacier storage class is designed to be the lowest cost Amazon S3 storage class, allowing you to archive large amounts of data at a very low cost. However, uh, you must consider the retrieval cost. You must consider the retrieval cost and retrieval times. Okay, and this is statement 1.4. Understand the concept of cloud economics. Let's start the first task statement, which is understand the concept of cloud economy. Make sure you know how using AWS can help save technical research away from managing on-premise infrastructure such as server acquisition uh, and maintenance, space management, cooling, and other elements related to running and organizing data centers according to requirements. We have mentioned this previous lesson. The AWS Well-Architected Framework suggests adopting and consumption model and paying only according to usage. Stop spending money on data centers and data centers operation instead. Ensure your overall efficiency, analyze and track your costs and usage, and then use OS managed service to reduce the overall cost of ownership. Remember, OS can offer low cost due to economies of scale. When you stop spending money on data centers and pay only according to usage, your technical research will be freed up and available to prioritize over activity. Activities such as optimizing resource utilization, creating more efficient application, developing better activities such as optimizing resource utilization, creating more efficient application, developing better and user experience and money order areas that will help your organization streamline operation and generate more revenue. Next, capital expenditure or CapEx. There are costs associated with creating long-term benefits such as purchasing buildings, servers, printers, and backup power. CapEx items are generally purchased once and are expected to serve your organization for many years. Next, labor costs. Labor costs for living in an on-premise or data center environment, such as network operations center technicians who handle installation configurations, troubleshooting, and management of your servers and infrastructure. The next, software revision impact. The impact on software licensing costs when moving or migrating to iOS. It's important to understand how your current software license might be affected by moving to iOS. Can license be transferred or is a different license required? Can you give up current license in favor of iOS managed license? All of these questions must be considered when evaluating the economics of operating in the cloud. Do you know which operation will reduce costs by moving to iOS? Usually, it is not direct transition. Some application can be moved directly to iOS, but there are often additional things to consider to make it the most economical option. Do you know how to establish establish benchmark and performance testing instead of focusing on provisioning for peak demand? Automation is also important and can help reduce costs. As we mentioned in previous lesson, there can be cost saving by scaling horizontally to meet your demand compared to running on promise and operating at peak capacity. When you are not at peak demand, additionally, leveraging data segmentation and target reporting can also help reduce your compliance scope and save time during audits. Also, consider how much using managed services can help reduce your technical workload and costs for various use cases. For the executive departed into right sizing, adding automation, and curing complaints its made and reducing that scope and using our as managed service, all of which are covered in the AWS Well-Architected Framework. We will dive deeper into our service in domain 3, cloud technology and service. I know I have mentioned many different service benefits. And so thank you. And this is my presentation. Wassalamualaikum warahmatullahi wabarakatuh.